Hello, I'm Clive Watts. I'm the Director of Product Management at Secure Thingz Limited, based in Cambridge, UK. The title of my topic today is Planning for the Protection of Your Product IP through the Volume Curve. Let's start by taking a look at the process of moving a design from an OEM through to a contract production facility. It's tempting to think that this is really an easy process. Hardware engineers are done, software is done and completed, and our test engineer on the left-hand side here is given the go-ahead that everything's running as it's supposed to be. So we round up the files and send them all over to the production facility, and they can just get started, right? Well, as we all know, it's not that simple. And one of the aspects that makes this complicated is that typically we're on a volume curve here through to production. We don't just start with high volume production. Typically, we start with lower volumes and we ramp up over a period of time until it gets to be the maximum volume that we want for our product. So what does this volume curve look like? Because we need our security aspects of the product to follow that volume curve, despite the fact that we might have roles that are distributed and facilities that are geographically located away from the OEM. As an OEM developer, we'd first typically make perhaps our very first prototype board, the only one that ever existed, the first one whose blinky LED blinked. We might make that in-house through some painful process of assembly and test, and then get that working. A little bit later, we're going to need a few more boards. We're going to need to spread these around the software engineers, we're going to spread them around the test facility, so we might be making 10 boards. A bit further down the road, we need even higher numbers. Perhaps we're starting to get these in the hands of a few people who are demoing to customers, a few field application engineers. We might need 25 boards. And a bit later, when confidence builds in the product, we start to get to our first production batch. So perhaps here we're making 100 boards that go out to some lead customers, to exhibitions, to really start the process of selling and marketing this new product. And only when we're done with that curve of production will we actually move to volume production and make our first 5,000, 10,000 or whatever it is units that go out into the shops and start to make money for us. At every point along this curve, we have the risk that somebody will inject malware into our product, someone that will steal into our intellectual property and disrupt the development of the product. So we have to make sure that we think about security at every stage along this volume curve, all the way from the very first prototype right the way through to volume production. So even looking at design itself, there are many different roles within the OEM. And with those different roles come different risks. Of course, we have software engineers, we have hardware engineers, and finally we have the integration and test engineers. If you're lucky, these are all located in the same building and you have some control over who they are. But typically these people may be distributed. You might be using contract software developers or perhaps an external design house. Your hardware engineers might be in a different facility, and your test and integration engineer may be done in another country. And every one of these people brings their own danger. They can't be trusted to actually look after your intellectual property against their own interests. Interestingly, the photograph that I have on the left here was taken from a stock library, and it was entitled Software Engineer Working in the Adriatic, just as an example of the kind of distribution that we might have. What we need really is a trusted production planner sort of function. This is somebody who can securely connect the OEM with the production facility. Someone who can make sure that our intellectual property makes it out of the OEM intact and into the production facility intact. We kind of need a tunnel here from the OEM facility all the way to the production facility, something that protects that intellectual property on its journey from one to the other. Those of you that are familiar with VPNs, and I guess most of us are these days because of our working from home, you can think of this like needing a VPN that goes directly from the output of the OEM all the way through to the production facility. In fact, we really need a tunnel not just to the production facility, but all the way through to an individual production machine. We need to be able to pipe that intellectual property from the production planner role all the way through onto a production machine, so reducing the attack surface along that transfer process. Maybe we might need to think about a group of machines where there's very high volume, because it's unlikely that a single machine will be responsible for all production. So how can we achieve security all the way through this volume curve? Let's take a look at this in a little bit more detail now. What we really need to help with this process is a secure vault where we can keep all of our critical secure things. A place where we can create an identity, a place where we can create a certificate that represents that identity, a place where we can encrypt things and decrypt things, and a place where we can keep our valuable keys that are used to lock and unlock our valuable intellectual property. So what we really need is some kind of a specialized hardware security module. This is really key, critical, essential technology for the effective transfer, secure transfer of intellectual property. A couple of key criteria for this HSM. Obviously, this needs to be able to be secure in itself by design, so it cannot be interfered with. And very importantly, this needs to be able to operate standalone, because production facilities are regularly, clearly not connected to the internet for security purposes. So we can't rely on an external server being available on the internet, or perhaps even a server within the building being available. So how does all of this work in practice? So our production planner here is the end of the process of development at the OEM. He or she can collect together all of the application firmware, the secure boot manager, any configuration and other data that may be relevant to the application, and store that securely in an HSM. At the production end, our production machine can be equipped with an equivalent HSM deep inside the machine. And then we can create our connection, our VPN if you like, between those two devices, so that we can securely transfer all the way from the production planner through to the production machine. And of course that transfer is encrypted, so that if someone else picks up that transfer in the process, they're unable to do anything with the contents of that production package. Bearing in mind the volume curve scenario that we looked at earlier on, we're going to need a desktop solution for prototyping within the OEM or at local contractors. We can take the same scenario of storing the information within an HSM at the OEM, and secondly, produce a desktop provisioner setup, which will enable us to do the same thing as the production machine does, but in a local setup that can be configured within a lab or at an engineer's desk. In this case, we're using the same HSM, and we're obviously doing the same transfer of a production package between the two HSMs. And the desktop provisioner here will actually go through the same process of unpacking that encrypted transfer and programming that information into the target board, target system. So we have these two different solutions. One for volume provisioning, where we embed an HSM inside a machine, and two, a desktop system, where we can just carry out the necessary operations in the lab. We can extend that level of security by actually transferring the information, the firmware, the secure boot manager, configuration and identity directly into the chip itself through an encrypted transfer directly into the part itself, and placing into secure storage the identity that's been generated, any keys, the secure boot manager directly into memory. And this completes the chain of security all the way through from the OEM right through to the individual chip. So some of you will have spotted that we haven't yet dealt with the problem of the different internal actors who may themselves be compromised and affecting the security of the product. Software engineers, hardware engineers, test and development engineers. We've developed a system whereby that intellectual property internally can be protected by development keys, which represent those which will be used in a production environment. But when these are moved to the trusted production planner, those keys are replaced by production keys, which are held very closely, typically within an HSM themselves, so that the output to production uses a different set of keys which are not available to the engineers and prevents them from altering or affecting that final production package. As you will have realized by now, executing a volume ramp involves a significant number of different players, not only the OEMs who are creating the intellectual property to be programmed and the programming center that will create that inside the devices to be used on the final product, but of course other organizations like the silicon platform vendors themselves, contract manufacturers downstream, and even the end users themselves when we start to look at update of products in the field as security vulnerabilities appear and need to be addressed. So to illustrate the kind of partnership that's needed to secure the supply chain, here's a little bit of information about our partnership with EPS Global. So EPS Global is a manufacturer of programming equipment, and they also operate programming services, and we'll hear from them in a moment with a short video. Essentially, we're working with them to integrate our technology for secure production into their existing manufacturing machines and process. Let's hear from EPS how they see security in their environment.
Tier 1 electronics manufacturers across the world are outsourcing their IC programming and secure provisioning to EPS Global and benefiting from reduced costs, increased productivity, and flexibility. To protect IoT devices, security must be built in from the initial application design and throughout the supply chain, but can be challenging to implement. Our mission is to provide simple, cost-effective, secure provisioning services from our state-of-the-art programming centers, strategically located in all major electronic manufacturing hubs worldwide. We enable customers to get secure, connected products to market by leveraging our experienced staff and in-house production technology throughout our global network. We maintain a world-class quality level, compliant with all international quality control standards, including German automotive quality standards. We support all programmable package types at any volumes, including multi-chip packages with long cycle times, such as eMMC and UFS. 3D coplanarity checks are completed on all devices to solve handling problems on high pin count devices. We also offer extensive tape and reel services and manufacture our own carrier tape for components of any shape to help our partners eliminate manual insertion cycles in their processes. Own your own supply chain, control your costs, streamline your manufacturing, and build a truly secure IoT product that is protected from intrusion, counterfeiting, and overproduction. If you are looking for a reliable, flexible IC programming and secure provisioning partner, talk to us today. See what we can do to help.
So having understood what EPS do and how they view security from their perspective as a programming services provider, let's have a quick look at how we're working with them to actually integrate our two solutions together. Here you can see a network of machines that are being operated on the shop floor. And what we've been doing is to take our security appliance, our specialized HSM, and to integrate that inside their machines. This diagram on the right shows you a close-up of where the device programmer is, this unit on the right-hand side. And we've worked closely in partnership with EPS and the supplier of the programmer to integrate our security appliance with that environment so that they collaborate and coordinate in terms of providing a secure programming service. So thank you for listening today. If you'd like to learn more information about our implementation that solves these problems, please visit iar.com and securethingz.com. I think we have a few minutes left. If you'd like to ask any questions, I'll be happy to take those now. And I think there'll probably be a breakout room after the session where I'll be available for up to 10 minutes to take any further detailed questions from you. Thank you again.